Hello students, today we start a topic. A transist consists of the following essential part. So in a last lecture we discussed up to the A-frame, means up to three part we discuss about the transist theodolite, and now we discuss about the another part is leveling head. So already three part is already discussed. Now we start a new part of the theodolite is a leveling head. So here leveling head is used to attach the instrument on a tripod stand. So here in a leveling head, uh, this screw is provided. So it's called a leveling screw, or also called a foot screw for adjustment of the level to instrument. And the leveling head consists of a two parallel plate is known as a tri-bridge plates, and these plates are parallel with each other by using the foot screw. And generally there are the three step are there in a theolite traversing. First first one is leveling, then first one is a centering, then after leveling, and third one is a focusing. So after centering, leveling is there. So in this leveling, by using the foot screw we level the theodolite leveling head plates. Now next is axis or two spindles. So there are the inner spindle or axis is a solid or conical, and the outer spindle axis is a hollow. So these are the axis, and this one is a spindle. So here the inner spindle also called upper axis, since it's carry a vernier or upper plate, and the outer spindle carry a scale or a lower plate. Now next is a lower plate. So here this plate, see this in this figure you exactly seen that lower plate is right at here, and in this plate angular horizontal plate gradually provided around the graduated circle with a 0 to 360 degree in a clockwise direction, and the graduation are in a degree divided into three part, and each division has a equal 20 minutes. So each and every 20 minutes 1 degree is done. So 1 degree is divided into three part, and horizontal angle are measured by using this plate. And here to measure the angle there are the two windows provided. First one is a window A and the second is a window B. So in a window A we measure the angle from the 00 degree, and in a window B we measure the angle from the 180 degree. And the size of the theodolite is defined by the diameter of the horizontal circle. So it's in a lower plate, diameter of the lower plate is you get the exact idea about the size of the theodolite. Like there are the many types of the theodolite is available in a market, but size is depend on a diameter of the theodolite. So like diameter start from the 12 centimeter to 15 centimeter, and generally usable theodolite is a 12 centimeter diameter plate. And next is the upper plate. So here see exactly here above the lower plate upper plate is provided. So horizontal plate of a smaller diameter is provided with a two vernier on diametrically opposite part of its circumference, and vernier are designated A and B, and they are used re to fraction of the horizontal circle plate graduation. So here vernier graduated in 20 minutes, means each minute is divided into 3 to 5 parts, and least count is a 20 minute or 10 minutes, sorry 20 second or 10 seconds. Now next is the upper and lower clamp screw. So what is upper and what is lower clamp screw? So here screw is provided, upper clamp plate and lower screw is provided. So here lower screw is here and upper screw is here. So these both the screw are provided to fix the two plate, or two clamps are assigned to target the screw with the plate, and these screw are facilitated to motion of the instrument in a horizontal plane. So when we fix the upper screw or upper clamp screw, so both the plate are fixed, and when we target the any point or any object, and when we measure the angle, so first one upper screw is fixed, and when we fix the upper screw both the plate are fixed, and no moving of the angles. And in a lower screw, when we fix the lower screw, rotation of the theodolite is fixed, and no rotation is done after fixing the lower screw. When we rotate the telescope or a theodolite in a horizontal direction, so compulsory required lose the lower screw. Now here lower clamp screw lock the or release the lower plate, and when the screw are unblock the upper plate, and the lower plates move together and associated with a target screw allow a small motion of the plate in a lock position. And upper clamp screw locks or release the upper vernier plate, and which clamp is released, the lower plate does not move, upper vernier plate move with the instruments, and this causes change in reading, and the upper tangent screw allow the fine adjustment. Now next important part is leveling tube. So here see this circle, small circle is given at here. So in this from the top view, this type of the tube is provided. This type of the tube is provided at the uh, top of the upper plate, and this level tube is generally used to find out the your instrument is perfectly leveled or not. And spirit level with a bubble and graduated on a glass is covered, and single level or two levels fixed in a perpendicular direction may be provided, and the spirit level can be adjusted with a foot screw of the leveling head. And when the bubble is at a center of the tube, means your instrument is perfectly leveled. Now next is a plumb bob. So here one string is provided, and below the string plumb bob is provided. So there are the different type of the plumb bob is available, but generally we use the metal plumb bob in theodolite. So here plumb bob is suspended from the hook fitted on the top of fitted to the bottom of the inner axis, and it is used to center the instrument exactly over the station. So here when we fix the tripod stand above the exactly above the station, so by using the plumb bob, direct instrument is directly fixed above exactly above the station or a wooden peg. Now next is a compass. So all of you know about the compass. So compass is generally used to direct the north direction, because here needle is provided in a compass. So needle is always rest in a north south direction, and in a compass north direction is seen by the red mark. And some theodolite are provided with a compass, and bearing are taken from the compass, and it is fitted to a A-frame. So here in this A-frame compass is fitted, and by using this compass with respect to north direction, we measure all the angles, all the horizontal angle we measure with respect to north direction. Next is a shifting head. So here an arrangement of the shifting head is made for a quick and accurate centering of the theodolite. So all the setup is move in a horizontal direction in any direction, and When the arrangement is fixed, so shifting aid is the lock, and then after by arrangement of the theodolite can be shifted in a horizontal plate with respect to tripod stand. So in a tripod stand we exactly fix your center and fix your station above the instrument. And next is altitude level tube. So highly sensitive bubble is used level particularly when taking the vertical angle observation. So here work altitude level tube is working is the same as a level tube. So it's a highly sensitive bubble tube. And for the vertical angle, we first we check the altitude level tube, and then after we measure the vertical angle. Now next topic we start with some of the definition and technical terms. So here first definition is centering. So what is centering? Centering means setting the theodolite exactly over an instrument station so that the vertical axis lies immediately above the station mark, and it can be done means by the plumb bob suspended from the small hook attached to the vertical axis of the theodolite, and the center shifting the arrangement is provided if the instrument is with the help of the instrument in easy and rapid performance of the centering. So here when we fix the station, and then after when we fix the uh, wooden peg on a ground, and then after instrument is set above the ground, so by using the plumb bob centering is done. Clear? So all of you know about the centering. And if a small movement is required, so shifting head, by using the shifting head we shift the theodolite in any direction, and fix the shifting head, and we exactly centered the instrumentation above to theodolite machine. And next is a transisting. So transisting is known as a plunging or reversing. It is the process of turning the telescope about in a horizontal axis through 180 degree in a vertical plane. So bring it up and down and making it point exactly opposite in a direction. So here transisting like movement or rotate the telescope in a 180 degree, means in a backward direction, where when we seen the forward direction any ranging rod, and directly we seen the backward direction ranging rod, so we easily rotate the telescope in a 180 degree and bisect the backward direction ranging rod. So it's called a transisting. So transisting is a rotate the telescope in a vertical direction, not in a horizontal direction. Next is swing the telescope. So what is swing? So swing means turning the telescope about in a vertical axis in the horizontal plane. So swing is right to left according to the telescope is rotated clockwise or a counterclockwise direction. So it's called a swing the telescope. Next is phase left. So this type of the definition asked in a G2 examination in a 3 marks, like three definition is given, and write all these three definitions. So another definition is face left position. So if the vertical circle of the instrument is on left side of the observer while taking the reading, the position is called a face left, and the observation taken in a horizontal or vertical is in position is known as a face left observation. So here from the telescope, vertical circle which are measure the vertical angle. So this vertical circle is in a left side of the left side of the instrument, so it's called a phase left position. So all the readings generally we take a phase left position. And what is phase right position? So when the vertical axis is in a right side of the instrument is a right side of the observer while taking the reading, the position is known as a phase right position. And the observer taken the horizontal and vertical circle is in a position is known as a phase right observation. Now next type of the definition is a changing phase. So what is changing phase? So it is the operation of bringing the vertical circle to right of the observer if originally it is to the left side, and vice versa. So means when we position is changed from phase left to phase right position, so it's called a changing a phase. So it is done in a two step. First revolve the telescope through 180 degree and in a vertical plane, and rotate it through in a 180-degree horizontal plane. So here two step is there. First rotate in a 180-degree horizontal, and second is a 180-degree vertical. So these two step we change the phase of a theodolite. Next is a line of the collimation. So it is the line of sight and imaginary line joining the intersection of the crosshair of a diaphragm to the optical center of the object glass, and it's a continuation. And this line of collimation is passing from the center of the instrument telescope, so from the object van and from the eye van. So this line is transfer, it's a imaginary line, and transfer from the center, and also transfer from the diaphragm, means from the crosshair. Imaginary line is a pass from the center point. Next is the axis of telescope. So here it is known as a imaginary line joining the optical center of the object glass to the center of the eyepiece. It's a one type of the axis of telescope is a one type of the line of collimation. So both the line are passing from the center of the uh, telescope. Next is the axis of level tube. So it is also called a bubble line. So it is the straight or line tangential or longitudinal curve of the level tube center of the tube, and it is horizontal when bubble is in a center. Next is a vertical axis. So vertical axis, from the name you exactly seen that vertical axis means axis about which the telescope can be rotated in a horizontal plane, means telescope is in a horizontal direction and vertical axis is there. So telescope is rotated in a horizontal plane is known as a vertical axis. And horizontal axis, it is the axis about which telescope can be rotated in a vertical plane. Means this one is a telescope, and horizontal axis is passed from the telescope, and telescope is rotated in a vertical direction, means clockwise or anti-clockwise we rotate the telescope is known as a horizontal axis. And horizontal axis is also known as a Trunnion axis. Now next is adjustment of the theolite. So in the next lecture we discuss about the adjustment of the theolite. So there are the two type of the adjustment, permanent and temporary adjustment. Now we here complete our topic. Thank you.